This is AQA A-Level Chemistry. We're on the alkanes topic from Year 12, and this is part 3, where we will consider the combustion of alkanes. Try every section as you go, and then you get to see what you're confident on and what might need a little bit more work. So, some simple questions to begin about the products of complete and incomplete combustion. And with these, it's really important that you read the full question when you're going through, because it might specify that one of the products is solid or that all products are gaseous, certainly in the context of incomplete combustion. Complete combustion of a hydrocarbon, we get CO2 and H2O. If we look at incomplete, but both are gaseous, it's CO and H2O, carbon monoxide. And if we have a solid product in incomplete combustion, we would expect that to be carbon, soot, and H2O. You'll notice water is always produced. If there's not enough oxygen to produce water, we end up with unreacted hydrocarbons being released. So with that in mind, let's have a go at some equations. Try to write out these equations for me, please. So, complete combustion of methane, we know we're making CO2 and H2O, we know that oxygen is diatomic. To balance that, I need 2 O2 and 2 H2O. And I'm adding the state symbols in as well. They're all gaseous because when we combust methane, we get water vapour as the product. On the next one, we are combusting methane once again, but we're making gaseous products during incomplete combustion. So that's CO and H2O. Now on this one, we need to do the balancing slightly differently. It's not going to look the same. We've got 2 H2O again, but only 1.5 H2O, 1.5 O2. And I put the state symbols in once again. And finally, if we're doing this making a solid product, we're going to make carbon. The balancing here is 2 H2O, but it's 1 O2. And you can actually map here the decreased use of oxygen because there is a decreased supply of oxygen going from 2 at complete to 1 for incomplete, making carbon. State symbols added once again. You'll notice that carbon is a solid there. Let's do the same with hexane. So, hexane, we get C6H14 and O2. We're making CO2 and H2O again. So I balance my carbons, I balance my hydrogens, and then finally, I balance my oxygens, 9.5 O2. Put my state symbols in. And this time, we've got hexane, which is a liquid. It's from the petrol fraction, so we'd expect it to be a liquid at room temperature. But what about if we're making carbon monoxide and water? Well, I balance the carbon and hydrogen once again, and this time to balance the oxygens, I only need 6.5 O2. So if my supply of oxygen is limited, you can see why that will be the outcome. Once again, state symbols go in. And finally, what happens if there's even less oxygen and we make C and H2O? Once again, I balance my carbons, I balance my hydrogens, and this time I only need 3.5 O2. State symbols in there, and again, just to highlight this, 9.5, 6.5, 3.5, as we go further away from complete combustion. A little bit of a synoptic question here, taking us to a different topic. These are all useful as fuels, hydrocarbons or alkanes. Why? Well, exothermic means that they release heat energy to the surroundings, which is what we would expect a fuel to do. Now, we also need to prove what the products of combustion are. So how can this experiment prove that carbon dioxide and water vapour are produced? And why do we use the water pump? So the water vapour condenses in this U-tube where it's passing through an ice bath. You could also put cobalt chloride paper in there that would turn blue to pink, and you may be familiar with that test. In terms of the carbon dioxide, we would prove its presence by bubbling it through the lime water, and the lime water would go cloudy. And the purpose of the water pump is that will draw the product of combustion through the system. Okay, for this, it's about looking at how we get these pollutants that we need to be familiar with. Where do they come from and what problems do they cause? So, once again, I'm going to recommend you try this and then unpause when you're ready to review. So carbon monoxide we already know comes from the incomplete combustion of fuels. We've already seen examples of that. Carbon monoxide is a toxic gas. It causes suffocation. So it is a serious problem at ground level, to us at a very personal level. If we move on to nitrogen oxides, so this is where nitrogen goes into car engines at very high temperature and is actually able to be combusted. So that might be N2 plus 2O2 goes to 2NO2. We also have nitrogen monoxide as a possible oxide. And the problem we associate with nitrogen oxides is that they dissolve in rainwater to form acid rain. If we look at sulfur dioxide, that comes from sulfur impurities in fossil fuels. And if you combust the fossil fuel, we end up making sulfur dioxide. Once again, that sulfur dioxide dissolves in rainwater to form acid rain. 3 more pollutants to consider. And let's take a look at these. So carbon particles, again, we already know comes from incomplete combustion of fuels. And we've already done the equations, but I've put another one in there briefly. Now, if we get soot, that's going to lead to breathing difficulties. You might also read about something called global dimming. Unburnt hydrocarbons, as I explained earlier, come when we have a very, very limited amount of oxygen, maybe so little we can't combust at all. So there is no equation for that. And the problem we associate with it is we might get photochemical smog and again, breathing difficulties. Finally, water vapour. And the water vapour comes from combustion of fuels. Seen many examples. I've done complete combustion of methane there. And it's actually the predominant global warming gas. 60% of the global warming gases that exist are water vapour. But it stays in the atmosphere for a shorter time because it's part of the water cycle. So if we look at tackling pollution, we have some specific examples. We're going to look at 1 or 2 of those here. The first is flue gas desulfurization. This is trying to remove the sulfur rather than allow sulfur dioxide to form and to make acid rain. Have a go at these questions. And in the first case, S plus O2 goes to SO2, and it gives you a lot of the information on the next one, that we would take SO2, H2O, and half O2, and that would make sulfuric acid. That then falls as acid rain. So in terms of flue gas desulfurization, again, a lot of information provided here. Have a go at writing this equation out. So we're told that calcium oxide reacts with water and oxygen and sulfur dioxide, and we're told what the product is. The only thing we then have to do is balance it, and that's what we have here. Now in the next video we'll look at another example of reducing pollution, the catalytic converter, but for now that takes us to the end of this section. Thank you for listening and goodbye.